We're going to go ahead and look at lesson 4.1. We start with the roots in Pythagorean theorem. Roots are a way we use to solve equations like quadratic equations. And so now what we're going to progress ourselves to is something called the power equation, which looks like this here. Y equals x to the power of some number other than 1. 2 is for quadratic. Here's an example of two equations. They're both called power equations. This one has a specific name called the quadratic because of the 2. This is a cubic because of the 3. But in general, those are called power equations as it's stated here. And so this first part is kind of an introduction of what is a root, a square root, and then what is also a how we use these square roots to undo or solve equations. And so you can see the relationship. When you take the square root of x squared, it simplifies to x because square roots ask you the question, what multiplied with itself equals 9 in this case? And you would say 3 times 3. Looking ahead to an equation, what's the solution to x squared equals 81? Well, when you first introduced to a problem like that, you're asking yourself, what times what equals 81? So mentally, you can just figure that out. That's 9 times 9. But algebraically, you take the square root of both sides, and then square root of 81, what multiply with itself equals 81 equals 9. But notice that we have another solution. The negative 9 times negative 9 also equals 81. So we end up with two solutions when you solve a quadratic of this form. So for example, solving x squared equals b, or any number, your solution will always follow this form. X is equal to square root of b and negative square root of b. Notice how those are connected. So we sometimes simplify this notation. Instead of writing two separate solutions, we write it as one, saying x equals plus or minus 1. We have an example here, x squared equals 41. What multiplied with itself equals 41? Well, mentally I can't do that, but I do know the answer is x is equal to square root of 41, and x is equal to negative square root of 41. And so what that looks like, this could have also been written that way. And that is a solution. You can leave the answer that way, unless you need the decimal version. And so then you end up with those two answers there. And so again, to get those answers, you need a calculator, decimals I suggest. And then you could go ahead and put in square root of 41. And notice then there's your answer right there, 6.403, which is what we had right here. And so in some cases, of course, all equations are not going to be that easy to solve, but we have ones that will look a little bit more complex, such as this one here, x squared divided by 5 minus 3 equals 4. Take a look at the series of steps you use to solve this. It's exactly like what we do with linear equations. So just like if we were solving linear equations, if it was x over 5 minus 3 equals 4, notice on the linear equation, you would do these same steps. So the same thing works until you get all the way down to x squared equals 35. You would do the same steps here. Add 3, x over 5 equals 7, and then you multiply both sides by 5. So the rules don't change. All that will change is what happens when you get to the x squared part. You take the square root of both sides, and then you end up with both of those. And then, of course, that can be converted into its decimal. And so I get 5.9 5.916. And so in this case, you could also say your answer is x equals plus or minus square root 35, which equals plus or minus 5.916. Okay, in the next video, we'll take a look at solving more equations.